Hello everyone. In this video, we are going to discuss about the Darcy-Weisbach equation for head loss due to friction when there is a flow through pipe. And before that, let's discuss about the energy losses. Energy losses when fluid is flowing through pipe, right? The fluid experiences some resistance due to which some of the energy of the fluid is lost. And it's mainly classified as the major energy losses and the minor energy losses. If you see that the major energy losses is due to the friction of the pipe wall maybe, right? And it can be calculated using the Darcy-Weisbach formula or the Chase's formula. And the minor energy losses you can see here. And if you want to figure out the Darcy-Weisbach equation for the head loss due to friction, this is a pipe, right? Cylindrical shaped pipe, and there is a fluid flow. This is the direction by which the fluid is flowing in, and this is the direction of the flow out, right? Fluid out. And this is section 1 and this is section 2. You can see that the pressure acting at section 1 is P1 and the pressure acting at section 2 is P2, and the length is L. Okay, and definitely as the flow is in this direction, so there will be friction in the opposite direction, so we will call it the frictional resistance. In order to figure out the value of this head loss due to friction, what we are going to do is we are going to apply the Bernoulli's equation at section 1 and section 2. We know that the Bernoulli's equation is P1 by rho g plus V1 square by 2g plus Z1. This is going to be the head at 1 and this is going to be the head at 2 as the pressure is P2, and then the loss due to the friction between 1 to 2. That means the loss due to the friction, the loss of head, right? Head loss due to the friction between this length, right? Where we are actually analyzing or observing, that is capital L. In that length, the loss due to friction is HF. Okay, this is what I have named as HF. You can see. Okay, so the head at 1 will be equal to the total head at 2 plus the loss that has occurred because of the flow of the fluid, right? So we can write it like this, and then you have just applied the Bernoulli's equation at head 1, head 2, and of course the loss due to friction between 1 to 2. Now, if you want to figure out the value of HF, you can note one thing here. Z1 is certainly equal to Z2. Z1 was the distance or the height from the datum line, right? So here, as the pipe is horizontal, the height will be remaining same. So Z1 will be definitely equal to Z2, and the V1 is equal to V2. That means the velocities at section 1 and section 2 is definitely equal in this case as well. And because of the equality, we can write this equation like this, because V1 will be equal to V2, so these two terms are gone. Z1 is equal to Z2, so these two terms are also gone. So we can only be left with P1 by rho g, and here P2 by rho g, and HF. So HF will be equal to P1 by rho g minus P2 by rho g, and you can just write this, and P1 minus P2 will be equal to rho g HF. So this is my equation number 1. And now let's see how we can figure out the values. Frictional resistance that we already seen there, this frictional resistance, this will be named as F1, and this is proportional to AS into V square. Okay, and now what is this AS? What is this AS? This AS is the area of the weighted region or the weighted surface area of the weighted surface, which is only the perimeter times length. Okay, so this is P into L. I'm explaining it, no worries. P pi d into L. See, the friction will be acting along the surface, right? So the friction will be acting in this direction only on the perimeter or the weighted surface. So that is why you are taking the perimeter of this pipe. Okay, because you are taking that perimeter, and definitely this is pi d into L. Okay, and L is the length of the pipe. So because it is area, so the entire area of that weighted surface will be equal to what? This perimeter into the length. So you will get the weighted surface area. Okay, now In order to get rid of this proportionality sign, we need to bring in any proportionality constant. So we have seen that F1 is proportional to AS into V square. So F1, I can write F1 is equal to any constant will be there, and I'm assuming that is F prime into AS into V square, right? And this F prime you can see over here is the constant of proportionality. Now I will be calculating all the forces. All the forces are in the horizontal direction. How many forces are induced here? You can see P1. Because of this P1, there will be a force which is P1 into area. Because of this P2, there will be force which will be P2 into area. And there is another force which is the frictional resistance. Due to this, there will be another force. And the direction of this is not equal to this and this, right? The frictional force. So we'll also need to take that into consideration. So I am considering all the forces, right? You know that summation of forces I'm taking in the horizontal direction. Okay, so if you take that, you will find P1A and the other two forces due to P2A, it is in the opposite direction than P1. That is why I have taken negative sign here and negative F1. Okay, F1 equal to 0. And then you can find P1 minus P2 into A is equal to F1. And what is this F1? This F1 is the frictional resistance, right? And we have already figured out the value for this F1. So P1 minus P2 into A is equal to, what is the value for F1? F1 is F prime into area of the weighted area into V square. So you can write it like this: F prime, the weighted area was pi d into L into V square, right? So now what you will get is, you can also write it like this. Let me show you. P1 minus P2 will be equal to F prime. Pi d is the perimeter, so I am writing P L V square, and this A comes here A. So you can see that I have got the value of P1 minus P2, and previously I also got the P1 minus P2 at section in the equation number 1 by using the Bernoulli's equation. So I can definitely use this value there, right? This is the rho g HF, and I can use it here. So from 1 I can write, from 1 what I have got is a very good thing. Because of P1 minus P2 I can write rho g into HF, right? And then it will become equal to F prime. P is not pressure, it is the perimeter. P into L into V square over A. A is the area of the area due to the diameter, because this area I am talking about. Okay, and this area and at this time, this place, all the area is same, right? At section 1 and section 2, so there is no change in the area. So you can keep it as it is. You can take common here, right? So now rho g HF is equal to what? F prime P L V square over A. Okay, so now from here you are required to find the head loss, right? So HF can be separated and it can be written as equal to F prime divided by rho g and P upon A L V square. Now see that P is the perimeter, which can be written as HF is equal to P is the perimeter and it is pi d. Right, I'm writing d small d. I have taken the pi d, and the area is pi by 4 into d square. So from here you will be getting 4 by d, right? If you do the calculation, you will get 4 by d from here. So in place of p over a, you will get 4 by d. So I am writing f prime over rho g 4 over d into L into V square. So now it has become very easier for us to calculate, and we can get the results. This F prime is the Darcy's coefficient, and it's given as F W divided by 2G. This W is the specific weight, so it's written as F into rho into G divided by 2 into G. Okay, so now if you put this value of Darcy's coefficient in this equation, this star equation, what you will get is the final answer, right? So from this equation you can get HF as just put all the values, okay, you will end up getting the result. So f prime is equal to f into rho into g divided by 2g, and you had rho g earlier, the main equation, 4 upon d, and you also got l into v square. So g got cancelled, rho and rho got cancelled, so you are only left with the result, which is 4f lv square over 2g into d, and this is the equation that we are required to find. So it is the proof. Now let's talk about this f, right? In this Darcy's coefficient, we have seen that we got introduced with this f. What is this f? This f is the coefficient of friction. So you can write here f is equal to coefficient of friction, and this is a function. This f, it is the function of Reynolds number. This is the function of Reynolds number, and its value will be equal to 16 over Reynolds number when Reynolds number is less than 2000, and because of the viscous flow. Okay, and this will be also equal to 0.079 divided by Reynolds number raised to the power 1 over 4 for the range of flow of Reynolds number between 4000 for Reynolds number 4000 to 10 raised to the power 6. So because of the uh, experimental value of Reynolds number, if the Reynolds number is 4000 to 10 to the power 6, you will use this value, and definitely you will have some Reynolds number, and this is how you define this f, or the coefficient of friction, okay, in this equation. And this is the proof. This is already proved, okay. So this is what is actually required from you in the exams point of view. So this is very easy. If I want to let's just talk about this L. This L is the length, right? This L is the length of what? Length of pi, right? This V is the velocity, or you can say the mean velocity, right? And this D is the diameter, and this G is the gravitational acceleration, right? And this F already has been discussed. All right, so you have already got this equation. Now if you were aware about the value of the velocity is given, you can use this formula. But what about the value of discharge is given, and you are required to find the value of the head loss? So in that case, if the discharge is given, I will write it here. Okay, if discharge is given, you know that the Q, discharge, is equal to A into V, where V is the velocity, is the area, and area of this pipe will be pi by 4 into d square, as the diameter is small d, and this is V. So from here you can find the, you can replace V with the Q, right? So V will be equal to 4Q upon pi d square. And if you just put this value here, you can get this equation for the head loss.